Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome to the App6 online support program. It's the weekly video lesson of Maths for grade 10. I am Kurtulan Said from the Maths Department of Senior Girls Wing APS Fort Road Rawalpindi. Our today's topic is nature of the roots of a quadratic equation. Now, let me share the objectives of today's lecture with you. By the end of this lecture, you will be able to find the discriminant of a quadratic equation. Use the discriminant to find the nature of the roots of a quadratic equation. Determine the nature of the roots of a quadratic equation and verify the result by solving the equation. Determine the value of an unknown involved in a given quadratic equation when the nature of its roots is given. The exercise related to this topic is exercise number 2.1, given on page number 22 of your book. Let's begin with question number 1. It says that find the discriminant of the following given quadratic equations. Here, you simply have to find the value of the discriminant b squared minus 4ac by comparing the given equation with the general form of quadratic equation. In the second question, we are being told to find the nature of the roots of the given quadratic equations and verify the result by solving the equations. So first, we'll evaluate the discriminant b squared minus 4ac to find the nature of the roots. Then we'll solve the equation by any method to verify the nature of the roots. Here, I'll solve one of the parts of question number 2 for you. This is question number 2, part 1. The given equation is x squared minus 23x plus 120 is equal to 0. Comparing it with the general quadratic equation, we get the values of ABC as 1, minus 23 and 120 respectively. The discriminant is equal to b squared minus 4ac. Inserting the values of ABC, we get the square of minus 23 minus the product of 4, 1 and 120. This results in 529 minus 480, which is equal to 49. Remember that the square of minus 23 gives positive 529. For question number 1, your solution will be up till this step. But for now, we have to further discuss the value of the discriminant to decide the nature of the roots. Coming back to the point, the discriminant is 49, which is a positive number and a perfect square of 7. As we know that when the discriminant is positive and a perfect square, the roots are real, rational, and distinct. Verification. For verifying the nature of the roots, we have to solve this quadratic equation by any of the three methods. I am using factorization to solve the equation x squared minus 23x plus 120 equal to 0. Splitting the middle term minus 23 into two parts minus 15x and minus 8x. Grouping the terms in pairs, taking the common factors out, in the end we get two factors x minus 15 and x minus 8. When the product of two factors is 0, either the first factor is 0 or the second factor is 0. So here either x minus 15 is 0 or x minus 8 is 0. Hence we get the two values of x, 8 and 15. These are the roots of the given quadratic equation. Observe that these roots are real, particularly rational, and distinct or unequal. Hence, it verifies our initial judgment about the roots that we made on the basis of the value of the discriminant. Before moving on to question number 3, consider this example again. We have observed this in the previous video that the discriminant b squared minus 4ac is 0. So the two roots obtained are equal and real. Now I am solving the same example again. Actually, I want to highlight an important point, so stay focused. Solving the quadratic equation by factorization, we get two similar factors, x minus 4 and x minus 4. See, their product becomes x minus 4 whole squared. This shows that the quadratic expression we made factors of is a perfect square. Solving further for the values of x, we get two equal roots x is equal to 4 each. This quadratic expression can also be factorized By applying second algebraic identity, a minus b whole squared is equal to a squared minus 2ab plus b squared. This makes it even more clear that this expression is a perfect square of x minus 4. Earlier we saw that the discriminant equal to 0 gave us equal roots, and now we found that this equation, which itself is a perfect square, gives equal roots. Combining both the statements, we can say that a quadratic equation, which is a perfect square itself, will always have equal roots and its discriminant will be 0. Students, don't get confused by the word quadratic expression or equation. Obviously, the left-hand side of the quadratic equation is an expression, and this expression has become a perfect square. But an expression cannot give the solution. To find the value of x, we need the right-hand side as well. So both sides together form a quadratic equation. Moving on to the question number 3 of exercise 2.1. In fact, both the questions 3 and 4 are of the same type. Here we have to find the value of an unknown involved in the quadratic equation when the nature of the roots is given. Now let's solve question 3 together. The question is, for what value of k, the expression k squared x squared plus 2 times k plus 1x plus 4 is a perfect square. Here k is the unknown constant and the nature of the roots is also given. You might be wondering, where is it given? Since it's written in the question that the given expression is a perfect square, this implies it has equal roots and its discriminant is 0, as we saw in the earlier example. But first we have to write this quadratic expression as a quadratic equation by putting it equal to 0. Now by comparing it with the standard quadratic equation, we get the values a is equal to k squared, b is equal to 2 times k plus 1, c is equal to 4. Now the discriminant is given by the expression b squared minus 4ac. Inserting the values of a, b, c. Here the square of b means the square of 2 times k plus 1, which means that the square is on 2 and on k plus 1 individually. That becomes 4 times k plus 1 whole squared minus the value of the term 4ac, that is 16k squared. Expanding k plus 1 whole squared, we get k squared plus 2k plus 1. Multiplying 4 with each term in the bracket gives us 4k squared plus 8k plus 4 minus the term 16k squared. Solving the like terms 4k squared and minus 16k squared, it gives minus 12k squared plus 8k plus 4. This is the value of the discriminant and it cannot be simplified further. Now by using the condition that as the given expression is a perfect square, so its discriminant must be 0. Substitute the value of the discriminant, taking out minus 4 as a common factor, dividing by minus 4, we get a simplified quadratic equation in k. On factorizing, we get the factors k minus 1 and 3k plus 1, whose product is 0. This suggests that either k minus 1 is 0 or 3k plus 1 is 0. That is, either k is equal to 1 or k is equal to minus 1 by 3. These are the possible values of the unknown k, which makes the given expression a perfect square. You can also verify this by actually substituting these values of k in the given expression one by one. Here is one more important point to be noted. These are the values of k, which is an unknown constant, so we don't write the solution set here. The solution set is only meant for the values of x. The question number 4 is just like question number 3. Here you have to find the value of k, the unknown constant, when the roots are equal. We know that for equal roots, the discriminant is equal to 0. So just find the discriminant and put its value equal to 0. Solve further to get the value or the values of k exactly like question number 3. Moving on to question number 5. Here, question number 5, 6 and 7 are of the same type. In each of these questions, the nature of the roots is given to us, along with the condition. In question number 5 and 7, that condition is given to us and we just have to verify it. Whereas in question number 6, we have to find that condition. But the procedure of solution for all these questions will be the same. Also, in all these questions, the roots of the given quadratic equation are equal. So from the word equal roots, what comes to your mind? Yes, the discriminant is equal to 0. Now let's solve the question number 5 together. The question says, show that the equation x squared plus mx plus c whole squared is equal to a squared has equal roots if c squared is equal to a squared times 1 plus m squared. Alright, so basically we are given that this quadratic equation has equal roots. For this purpose, we need to find its discriminant, which will be equal to 0. But to find the discriminant, we require the values of a, b and c. For that, first we'll bring this quadratic equation into the form of standard quadratic equation by expanding the square of mx plus c, like this. Here these three terms have appeared because of expanding the square by the first identity. Also, notice that the variable is x only. M, C and A are simply the constants. Now the first two terms have x squared in common, and a squared when shifted to left hand side becomes minus a squared. Now comparing this equation with the general form of the quadratic equation, here if you notice that the equation in the question also involves the constants a and c. So just to distinguish between them and the coefficients of the general quadratic equation, we write it like a prime x squared plus b prime x plus c prime is equal to 0. There is no other significance of using this a prime, b prime or c prime. Now we get the values as a prime is equal to 1 plus m squared, that is the coefficient of x squared, b prime is equal to 2mc, and c prime, that is the constant term, is c squared minus a squared. The discriminant will be given by b prime squared minus 4 times a prime c prime. Inserting the values in the discriminant, we get the square of 2mc minus 4 times the product of 1 plus m squared and c squared minus a squared. The square of 2mc is 4m squared c squared, and by expanding the product, we get these terms written inside the bracket. Now by multiplying each term of the bracket with minus 4 outside, we get the final form of this expression. Here, 4m square c square and minus 4m square c square will cancel each other. Therefore, the simplified form of the discriminant is this. Now using the fact that the given equation has equal roots, so its discriminant will be equal to 0. Putting the value of discriminant equal to 0, taking this minus 4 as a common factor. Now to get rid of this minus 4, we'll divide the equation by minus 4. Then separating the term c squared on the left hand side of the equation, we get c squared is equal to a squared plus m squared a squared. Now taking a squared as a common factor from the right hand side, we get c squared is equal to a squared times 1 plus m squared. Hence it is verified that this is the required condition for which the given equation has equal roots. Basically, all the questions from 3 to 7 are of the case of equal roots. That implies that discriminant is equal to 0. Moving on to the next question. In question number 8, we have to show that the roots of the given equations are rational. For the rational roots, basically we have to show that the discriminant is not only positive but a perfect square as well. Now I am solving the question number 8, part 1. The question is, show that the roots of the following equation are rational. Students, here we have to observe two things in this quadratic equation. Firstly, it is already in the form of the standard quadratic equation, so we can directly proceed towards finding the discriminant. Secondly, it already involves the constants a, b and c in it. So again we need to introduce a prime, b prime and c prime here for the coefficients of the standard quadratic equation. Now comparing it with the standard equation a prime x squared plus b prime x plus c prime is equal to 0, we get the values as a prime is equal to a into b minus c, b prime is equal to b into c minus a, and c prime is equal to c into a minus b. Now we'll find the discriminant and we'll show it a positive number and a perfect square, which is the required condition for the roots to be rational. Here the discriminant is given by b prime squared minus 4 times a prime c prime. Substituting the values in it, we get square of b into c minus a minus 4 times the product of a into b minus c and c into a minus b. Simplifying further, we get b squared into c minus a the whole squared minus 4ac times the product of b minus c and a minus b. Now we have to expand the square of c minus a and the product of b minus c and a minus b like this. In the next step, b squared will be multiplied with each term of the bracket. Similarly, minus 4ac has been multiplied with each term inside the bracket. Now we have got 7 terms in all. We observe that the only like terms are minus 2ab square c and 4ab square c. They will be simplified to make a single term 2ab squared c. Hence the 7 terms have reduced to 6 terms now. Since we are trying to show that this expression is a perfect square, we'll use the formula p plus q plus r the whole squared is equal to p squared plus q squared plus r squared plus 2pq plus 2qr plus 2pr. In the formula, there are 3 square terms and 3 product terms. So by comparing the resultant expression with the formula, we identify p as ab, q as bc and r as minus 2ac. Now substituting these values in the right hand side of the formula, we get the term p squared as the square of AB, the term q squared becomes square of BC, r squared becomes the square of minus 2AC, the term 2pq becomes 2 times AB into BC, the term 2qr is 2 times BC into minus 2AC, and the term 2pq is 2 times AB into minus 2AC. You can verify it by expanding each product. It should give the same term back. The reason of taking r equal to minus 2ac is that if you observe the expression, all the product terms involving c are negative. This suggests that its value should be taken as negative. Therefore, it becomes the whole squared of ab plus bc minus 2ac, that is, of the form p plus q plus r the whole squared. As a squared value always gives a positive answer, so the value of the discriminant is positive and a perfect square. Hence, the roots of the given equation are rational. In question number 9 and 10, we have to prove that the roots of the given quadratic equations are real. After evaluating the discriminant, you will observe that in both questions, the discriminant becomes a perfect square, which is of course positive, and hence the roots become real. Before you start solving the questions of the exercise 2.1, keep these few points in your mind. Remember to identify the values of ABC correctly while comparing the given quadratic equation with the equation ax squared plus bx plus c equal to 0. Remember to recognize the discriminant as b squared minus 4ac. Remember to analyze the value of discriminant carefully to find the nature of the roots. I hope you have understood all the concepts taught in this lecture. Thanks for your attention. Allah Hafiz.